solutions, one of the solutions is to use what we call in Starbucks. The second solution are package managers, virtual machines, container. Yeah, that's the left hand. It's not what it makes sense. Yeah. What is the difference? C'est quoi les dépendances? Par exemple, j'ai un outil pour faire de la livraison. C'est BWA, BWA. BWA pour fonctionner, il a besoin de d'autres logiciels en background qui lui permettent de fonctionner. Les logiciels qui permettent à BWA de fonctionner, c'est ce qu'on appelle les dépendances. When you have a job, over to this over to our competences. Si vous voulez créer un outil, vous avez besoin de quand vous étiez en train d'installer le truc depuis tout le monde, est-ce que vous avez installé avant que tout puisse fonctionner? Linux et quoi d'autre? What else? Linux c'est quoi? Donc pour que le Python puisse fonctionner, il a besoin de quoi? Il a besoin de Linux, d'AWS, et puis il a besoin de quoi? De Docker. Donc Docker et AWS représentent ce qu'on appelle des dépendances pour le Python. Alors comment gérer cette dépendance-là pour que ce soit transparent? Imaginez par exemple, vous avez un outil qui a 200-300 dépendances. Comment faire? Il faut trouver des solutions, n'est-ce pas? Il y a plusieurs solutions, plusieurs approches de solutions. Il y a des solutions basées sur les commandes de ce qu'on appelle des tables, et qui n'ont pas fait long feu. Après les tables, il y a eu ce qu'on appelle des package managers. Après, il y a eu des machines virtuelles et il y a eu ce qu'on appelle des containers. Donc, il y a plusieurs solutions pour gérer les dépendances. Et Conda, c'est un gestionnaire de dépendance. C'est en quelque sorte, c'est comme une boîte dans laquelle on va mettre tout notre outil et toutes les dépendances autour pour que l'outil puisse fonctionner. Et donc aujourd'hui, on va apprendre à travailler avec Conda. Donc on va apprendre à travailler avec Conda.
Has anybody here ever had the experience that when they update their computer, something breaks? Okay. And this is the thing. In the old days, with what Stanislas was calling tar balls, we would have one computer, one place, one copy of everything. Okay. And then, like, things would break all the time. Okay. The other thing is, who said package manager? Somebody said package manager. Okay. In the old days, we had to put it all in by ourselves, right? Now we have a recipe in Conda to basically say this, and then I go to another computer and I use the same recipe and it works. Now, this is what a package manager lets you do. Okay, I don't know if someone can say, I'll say, but yeah, but this is yeah. But to make it so that like wherever you go, you can do this and it works. So I don't know. I mean, who here drives cars? Nobody drives cars. Huh? Yeah, one of them drives cars. Okay, automatic or manual? Automatic. Then manual, automatic. If you learn to drive a car automatic, and then you do manual. It's actually going to relearn, right? It's so the same thing. It's like this thing. It manages all of the relearning for you. So you drive whichever car, no matter what.
Donc, pour gérer les dépendances, il y a plusieurs outils qui permettent de gérer les dépendances. Donc, on a représente un des outils pour gérer les dépendances. Il y a aussi Docker qu'on a l'habitude d'utiliser. Vous mettez tous vos éléments dans le vous utilisez votre conteneur comme une boîte, déplacez avec, dès que vous déplacez votre outil, vous déplacez l'outil avec toutes ces dépendances. Donc, vous n'avez pas à vous soucier des dépendances. Il y a deux informatiques. On a besoin de sécurité, on a besoin de connaître comment Conda fonctionne, on a besoin de connaître comment Docker fonctionne, et ainsi de suite. Si vous êtes dans une situation où vous devez créer des outils, vous êtes obligé de maîtriser ce que c'est Conda. Et donc, ce qu'on va faire maintenant, le premier TP, c'est d'installer Conda sur votre machine. Donc, premier, first one.
So we want to now install Conda.
Can I interrupt you? Can we rather start them with just illustrating? So what's happened with Conda is there's been some complications on the Conda side. So it's better to start with the actual people was not charging for some of their stuff. Okay, so better to start with MiniForge than this. Can we give them the link for MiniForge rather than that one?
If you share the link with me, yeah, I can.
Yeah, I'll share with you, Kirsty, because so MiniForge it starts with already Conda Forge installed, and it's more optimized than the Conda these days. I will send to Kirsty. She can share.
Can you tell the participants in the meantime not to follow this link?
Don't go to that link.
Ok. On va vous partager un autre lien, et MiniForge, où il y a tous les éléments à l'intérieur.
And then, sorry, Stanislav, the Windows people have been using their Ubuntu all day, right? They've been working in their Ubuntu all day, right? Okay, thank you. Okay. Now, let me make a terminal. Terminal. Okay. I'm going to make this bigger. So my computer's being a bit slow. I'm not making it bigger there. Yeah. I've already got it. So okay, I'm just going to clear this. Okay. First thing that you do, go to the link that Kirsty has sent you. Okay. It's the. Yeah, it has been sent to everybody, right? Yeah. So you go to the link. Starting point. First step. Everybody, have you got this page up? Can you see this page in your browser? Because I want to start everybody at the same place.
Slack, WhatsApp, and
Ok. Donc vous regardez soit dans le Slack ou dans le Google Doc.
Or you can just ask. You can just search mini forge.
Vous faites MiniForge.
I'm going to put my thing on. Pen that works. Good.
the back of the Africa CDC pen.
Ah. Look for this thing, MiniForge, okay? MiniForge. Okay? Then, once you found that, must unplug and plug in again.
I think maybe plug in and plug out here.
There you go. You did it. Okay. Mini Forge, okay? Then,
Vous cliquez sur le lien, le premier lien de Miniforge.
scroll down. We're looking for this section, okay? Now, you can see this. There's only two types of computers that we need to care about. Huh? Nobody's with M1 back here, huh? No. For the Windows, Ubuntu, this, huh? Even though you think it is Windows, with a WSL2, you are running Ubuntu, right? So, copy the Premier link, huh? Copy this first link. So, I'm going to go with my mouse, and I'm going to go. Where's my mouse? There. Right click, copy link. Okay? If you are on Mac, do the same thing, but down here, this. That's for Mac, okay? Which is, Osana is the only one with the Mac. Huh? Then, go to your terminal. wget. Right click, paste the link. Yes? Doesn't matter where you are. You can download anywhere. I'm just downloading my home directory. Doesn't matter where you are. We're going to delete it after. Just going to. I must just do one thing quickly. Don't even look at what I'm doing. I'm just going to do. Just hang on. Let me just do this. I must just get rid of my one so that I can. I'm going to move my mini conda out of the way quickly. Sorry, don't look at what I'm doing. Move mini forge. I'll put batches now. Yeah. Okay. And then it downloads this. Oops. And then it downloads this file. Miniforge, like so. Miniforge Linux, blah blah blah. Only thing with the Mac, I'm not sure if you use Chrome instead of wget. We'll see. We'll see when Hosanna does it. Okay? Wget and then that link. It's just these few steps which are very manual, and the rest is going to go. If you want in Chrome, right? So I want second thing, okay? ls Miniforge, it's there. Bash Miniforge. Bash BASH Miniforge. Yes? BASH space Miniforge. You want to run this download that you've got. So we go on, press enter, and now we get welcome to Miniforge. Welcome to Miniforge. In order to continue, it gives us this message. In order to continue, please review the license agreement. Press enter to continue. So press enter to continue. Okay? But you must see this screen. Now we get this whole thing. How to say? This explains the license for the software. Okay? All sorts of stuff. Do you agree with the license? We're just going to say yes. So space So here, like, you know, when you see this more thing, to finish reading, you can just press Q. Q. Okay? I want everybody to get to this line where it says, do you accept the license terms? Yes, no. You all seeing that? Then you say, yes, we. I'm going to say yes, and then press enter. Okay? Then it asks, where must I install? Just leave it where it says. Let it do what it says. Press enter. And it does this. Bum, bum, bum. It does some installing stuff. So I want everybody to get past those steps. Okay? At the last stage, so yes, lots of things happen. At the last stage, it asks you again, do you want to say yes or no? Say yes. Another time. Okay? And it does some things. Now you're back to the shell. Okay? If you're back to the shell, close your terminal and open it again. And when you open your terminal again, you will see base, then brackets. So if you are here, all is good. Otherwise, ask for help. If you got to here, and then Stanislav can take over again. It is root.
Must have this here. You must have base here. Base is the default container when you install component. You have to install Google environment for bioinformatics. So let's check. Type conduct space dot L. Alpha. Ok. Condat, c'est une commande qui a des sous-commandes. C'est condat list. List. What list? List. Yeah. The package in the condat environment. When you are in the environment, if you want to have the list of your command, condat list. First thing. Okay. Condat list. Qu'est-ce que condat list fait? Condat, c'est une commande avec des sous-commandes. Donc, on va parcourir un peu les sous-commandes. Qu'est-ce que condat list fait? Le paquet qu'il y a dans un environnement, n'est-ce pas? Alors, ok. Donc, tapez condat list. Condat list. Condat list. Voilà. Qu'est-ce que vous voyez? Ce que vous voyez installé là, c'est ce qu'on appelle là, des paquets. Ce sont des paquets qui sont installés là. Et donc, quand nous on va installer un outil, il va installer l'outil et ses dépendances. Et il va gérer les dépendances pour nous. Vous voyez que quand j'ai fait condat list, nous on a juste installé quoi? Condat, n'est-ce pas? Et lui, il a installé ça. Donc, c'est un gestionnaire de paquets. Nous, on demande quelque chose, lui, il s'occupe des dépendances. Et c'est pour ça que c'est très intéressant. Revenons encore à... On va regarder autre chose. Bien. Après Conda list, faisons Conda help encore. Il y a une commande qui s'appelle Conda create. Qu'est-ce que Conda create fait? Conda create. Yeah. So let's do this. Conda create dash help. That is fine. Okay. Now I want to create a new environment which name is beautiful. Conda create. Let's do the same thing with it. Conda create. Pourquoi, pourquoi on a besoin de créer un nouvel environnement? Why you need to create a new environment? Pourquoi on a besoin de créer un nouvel environnement? An environment for training. That you want to have an environment to do quality control. You can create an environment for quality control. You want to have environment for mapping. You can create an environment for mapping. You want to have an environment for variance colleagues and so on. Let's say you want to do quality control. You want to have an environment for quality control. You need to have to put two tools. First we see and we see that are usually used to do quality control. Let's create this environment.
Your base environment, which has a set of packages which you have seen. Now we want to create another tool which maybe performs fast QC or any other stuff. So you don't want to have all these additional packages installed in your base environment. So you create some other micro environment within that base environment. So you create, maybe this will be the fast QC. Fast QC. Now, for instance, if anything has problems within fast QC, you can easily delete this without affecting other stuff within your base environment. So that's a good practice.
Yeah.
So even different Python versions.
Yes. Even versions of the software have Python 3. Maybe 0.12 on your base environment, but the tool or the package you want to run requires 3.9.
Yeah.
So if you want to install 3.9, this will have some conflicts. But if you install it to a separate environment, it will be easier for you to install just for that particular package or tool you want to use.
Yes. Let's create a new environment for them. That name is Chrissy.
Yes. So we have to put channels.
say deal with channel before.
The other channels before.
Deal with channel before. Before we go to that.
All right. So this is the syntax you want to use when you want to create a new environment. So you have conda create. This stands n dash n. This stands for dash dash new. And then you have your environment name and the package you want to install. Okay. So can we just create without the package up to? Can you create conda create and new without SQLite, without the tool first?
And the environment is QC. Contact create. On va créer un nouvel environnement pour faire du contrôle qualité. Donc on va appeler l'environnement la QC. Conda create. Dash and QC for control quality. Yes.
Just put quality control.
Quality control. Control. Yes. Okay. Let's go for this. Let's see there. Driving all the dependencies from view conda, default, conda forward, and so on. Yes. And clear.
Quality control. Now we want to add the tools we're going to use to perform quality control.
Donc, on a créé l'environnement pour faire ce qu'on a appelé quality control. Mais on a besoin des outils pour pouvoir faire le contrôle qualité. On va installer des outils.
So we're going to add two tools. The first tool is called Fast QC, and the second tool is called
Multi QC.
Multi QC. Okay. Yeah.
No, no. vous suivez, on va installer l'autre outil.
So we need now to store our tools we want to do, which is first QC. So we add folder. Folder install. We're going to install it from channel.
Let's try first QC.
First QC.
First PC. PC.
First we specify the channel. On each channel.
So it's in Biocon. I'm not sure if you open out the Biocon channel.
First PC.
Let's run it.
Okay.
So I don't know if everybody has those channels.
On a installé First PC.
Saying that the package cannot be found because it's in a different channel. So you have the on the default and the default channel, but it's in another channel called Biocon. So you need to add the channel to install the package.
S'il y a eu un problème,
Just like the command.
pourquoi ça ne va pas marcher? Ok. Normalement, quand vous installez un outil, il faut qu'il aille chercher l'outil quelque part. N'est-ce pas? Par défaut, là où il doit chercher les outils, ça s'appelle des channels. Si le channel où il doit aller prendre l'outil n'a pas été configuré sur votre boîte magique, il faut lui dire qu'il faut aller ici. Et le channel où il y a l'outil qu'on veut installer s'appelle BioConda. Donc la commande que vous devez taper, Conda config add channel BioConda. Voilà. Comme le channel est manquant, qu'est-ce qu'on va faire? On va l'ajouter. Conda config add channel BioConda. Config add channel BioConda. Allez-y. Ok. Et quand c'est fini, vous relancez l'installation. Est-ce que vous avez déjà pris la commande? Vous tapez contact add channel BioConda, vous faites entrer. Et puis on revient encore pour refaire. Conda installe. Allez-y. Ils sont First PC and free PC to visualize the quality of our space. What we have to do now is to create a folder for our data. Let's see, PWD. Je suis à l'intérieur des scripts. Donc je vais revenir en arrière. CD PWD. And create a new folder called data. MKG my data. Data in this folder. Vous faites un copier-coller de tout folder. in the import photo. Just my data. C'est bon? Je vais faire juste des choses. On va les analyser manuellement. Et puis après, vous allez écrire un script qui va faire la même chose.
So what are they meant? Where they meant to? They meant to. This is the data from the improv, and they know where to find this, right?
Yeah. Vous allez me faire un fast QC dessus, un multi QC. On regarde les résultats. Maintenant, vous allez écrire un script qui va faire la même chose au lieu de faire ça manuellement. Donc, on va y aller pour l'utilisation de fast QC. Comment est-ce qu'on utilise? Quand on a un outil, qu'est-ce qu'il faut faire? When you have a tool, you want to use it. On a déjà installé. Fast QC, always install. Fast QC.
Fast QC. Done.
Fast QC, yeah.
Okay.
Fast QC. Installé. Donc, il faut tirer L. Ok. Fast QC a beaucoup d'options.
That is a lot.
Beaucoup d'options.
Go to the top. Go to the top.
That's it. Donc, regardez. Fast QC, et puis je lui donne les séquences. Et Fast QC, je lui donne les séquences. Mais quand il va les analyser, il va envoyer les résultats quelque part. Donc, il faut qu'il nous envoie ça quelque part dans un répertoire qu'on appelle output. Donc, on va créer un répertoire qui s'appelle output. MKD out fast QC. MKD out fast QC. Venez sur le répertoire. Out FQC. Et donc tous les résultats de fast QC vont aller dans quoi? Out FQC. Ok, c'est bon. Et maintenant on fait fast QC. Les séquences sont où? Dans My Data, n'est-ce pas? Donc, My Data, je prends la première séquence underscore 1. Donc voici la première séquence que je lui fournis. Je peux le fournir en une seule fois. I will do step.
What? So you're going to do it for the one and then the other, not together, right? Not ensemble.
I want to do one.
Let's do one.
One. Yeah.
It's going to be simpler because then later we'll put together.
Donc, on fait quoi? Fast QC, on lui donne le premier, moins O, out QC.
Out FQC.
Out FQC. Yeah. Le
Everyone
premier, on y va.
Before you run the tool. So some tools do create an output directory if you give it a name, okay? But some will require that output directory be there before running the tool. The safer option is always to create the output directory, okay? Because you have more control over that. So it's better to create the directory and then have the tool put your outputs or results into that directory. Even if the tool has the capability of creating the directory and then putting the results in that directory.
Will complain if the directory exists. So now option number one you must make the directive FastQC. Option number 2, it makes it for you. The third type of tool doesn't want the directory to exist because it's scared it's going to overwrite some data. So like Beast, for instance, if you give it an existing directory, it will say no, unless you say false. So yeah, so tools are different. What can I say?
Donc il est bon d'avoir vos résultats quelque part. Chaque fois que vous voulez produire des résultats, pour ne pas que ce soit mélangé ou bien dans tout ce que vous êtes en train de faire. Vous mettrez, chaque fois que vous faites un truc, il faut garder les résultats dans un répertoire. Ça, c'est l'attitude de on a c'est la bonne practice. Ok, maintenant, entrez. Il y a un problème pour moi. Chez moi, il y a un problème. Allez-y exécuter le vote. Ok, vous devez avoir ça. Voici ce que vous devez avoir. Ouais, c'est bon. Ok. Donc, si vous faites LS sur Auto FastQC, vous devez avoir une liste de fichiers. Il y a le fichier HTML et puis il y a le fichier zip. Maintenant, on va aller regarder le contenu du fichier HTML. Regardez ce que je vais faire. La dernière chose. Ok, voici le résultat du FastQC sur mon échantillon. Vous vous rappelez de ça?
The one thing we must teach them, if you're running on WSL2, where do you find your files from Windows? Okay. Let me just catch up with you and I'll show them. Just carry on. I'm just going to get 2 minutes to catch up.
Okay. Et donc, vous avez votre fichier de qualité. Et il y a un ensemble d'iconographiques et c'est ça que vous devez regarder pour ajuster.
Pour ceux qui ont ce système Linux, il dit qu'il va montrer où trouver des fichiers.
Yeah.
Ok. Pour le moment, il faut juste suivre.
6 minutes. Huh? But you go ahead with your description and I'll catch up, okay?
Donc vous avez ici, donc vous avez la qualité de vos. Et chaque élément, chaque élément, vous devez prendre en compte chaque élément. Première chose, si vous regardez les éléments d'une iconographie, vous devez être ouvert. N'est-ce pas? Ok. Basic statistique. Je vous dis par exemple qu'il y a 61 700 mégapaires de bases dans votre échantillon. Ouais, ok. Pour ce qui est de la qualité, ici, quand ça est dans le rouge, pour Illumina, ce qui est conseillé, c'est d'aller au moins jusqu'à ici, Q20. Maintenant, si vous avez des bases qui sont en dessous, c'est pas bon. Bon, ici, c'est juste vers la fin. Ce qu'il faut retenir, c'est que quand on a des fichiers illuminants, au début et à la fin, la qualité peut être mauvaise. Ça, c'est juste pour.
Wow, that's some nice quality, huh?
Yeah.
Wow. So just scroll up a little bit, please, Stanislas. Is that all at that high quality? Wow. That is nice.
It's been cleaned probably.
And cleaned, yeah.
Probably they have cleaned already there.
Of course, this is the pre-trimmed data because
Exactly.
they're getting from SOA.
Yeah. You have to look for the baddest one.
Voilà, maintenant, ici, vous voyez, c'est. Bon, ce sont des éléments, on va voir demain, je vais expliquer étape par étape comment on ajuste la qualité. Mais c'est.
Can I explain the first block to
Yeah.
translate before you move on? Okay. I'm just letting my computer do something. Let's go to the top again. Okay. Okay, people on Anglais, English. Okay. What do we see? Fast QC report. This is your meat and potatoes of quality control. Okay. You will be very used to this thing as a bioinformatician. Okay. First thing, I just want to point something out here that Stanislas didn't mention, okay? Fast Q, the name means fast A plus quality. The quality scores are written as letters, okay? But the letters mean numbers. The letters mean numbers in a thing called an encoding. So there's a translation, like for instance, if you see an H, it means a particular number. In the old days, there was lots of different ways of doing it. Now everything is done using this encoding called Sanger. Okay. Sometimes we refer to this as fast Q Sanger. That's confusing because people say, I don't mean Sanger sequencing, I'm doing Illumina sequencing. But the type of how the letters in the quality become numbers is called Sanger encoding. So it's called the Sanger version of FastQ, even though it's an Illumina machine. Just to make that clear, okay?
Il faut pas, si vous avez fait un Illumina que vous voyez par exemple dans une coding Illumina, il ne faut pas vous inquiéter. L'encodage, c'est un encodage, il y a plusieurs types d'encodage. Même quand vous faites de Oxford Nanopore, il peut utiliser un encodage standard qu'on appelle le Sanger Illumina. Donc il ne faut pas que ça vous inquiète. Ne dites pas, j'ai fait un Oxford Nanopore, et puis je vois qu'il y a un encodage Illumina. C'est juste un encodage.
Yeah, just the name. Total sequences, this many, this total bases, 61. Now, first quality control step that you do, okay? First QC step, the numbers are too low here, throw it out, okay? James and I were discussing this thing yesterday with Stephen, that the first thing is if you didn't get enough bases, maybe something went wrong with sequencing. We can't use it, okay?
Donc si vous avez par exemple la partie où vous avez écrit total base là, qui est très faible, c'est pas la peine d'utiliser les séquences.
Okay.
Par exemple, vous avez fait une séquence.
And the number will be different with the different machines. ISEQ. Sorry, give me a minute. Hey, Ben. Depending on what you're sequencing, which machine. Yeah.
They say there is no a limit, a baseline.
The lowest cutoff. Okay, so the number I think is a good one that that James said to me yesterday. If you take the smallest virus, okay, 7.5 kilobase virus or something like that, and you imagine 7,500, and let's say we want depth of 100, huh? 7,500 times 100, that gives you a minimum cutoff, right? But if we've got so the minimum number is going to change depending on what your organism is. Make it your thing.
Okay. So let's assume that the smallest virus is 2,000 bases. Okay? So it has 2,000 bases. And for you to cover the 2,000 bases 10 times, you need 2,000 times 10, right? So each position is covered 10 times, right? Okay, so we have 20,000 bases. Then we have to assume, let's say the longest Illumina read is 300 bases, correct? So we know longest Illumina is 300 bases. So to get the minimum number of reads we need, we would take the 20,000, because these are all the bases we need, we divide it by 300, right? And that gives us what?
60.
60? 66, right?
Something like that.
So we need at least 66 reads, each of length 300.
6,600, right? No, but it's not 66, but okay, we don't. I get what you're saying, yeah. But that is for the minimum. Just give me a second, please. But the thing is that we can approximately say that because we don't expect 10 time coverage, because if 10 was the average coverage, we'd be losing probably a lot of the virus. So let's say that we look, remember we're normalizing to say 200 in the normalization step, right? So let's say 200, okay, times 200,000, okay? Now let's take this down to a lower number. Let's make this, because 200 is like nice, but let's say we have some dropout. So let's just take about 200,000, which is the size of the genome, times, let's put 100, okay? So we just add 2 zeros, and it gives you an idea of how many reads we expect, okay? If we're dealing with Mycobacterium tuberculosis, it's going to M. tuberculosis, 4,4. That's how big the genome of Mycobacterium tuberculosis is, right? So if we want to have some coverage, 30 times coverage is typical for bacterial genome, we say times 30, okay? And then we get a number, and if our FastQC number, if our number of bases is a lot below that, we know there's a problem. So the base, maybe we say, this is good, and let's say we take that divided by, I don't know, 2 to give like a minimum or something like that. Whatever. It's going to be organism and machine and whatever specific, but you could get an idea. Then what you do, once you've figured out this idea from experience, you write it in your SOP for your lab. When you do the run, fill in this column. How many bases, okay? Because when you're doing your sequencing, right, and your bioinformatics, you must have a, some kind of a form where you're writing down everything about the sample, right? Because you're not just sequencing, like every lab must keep track of data for quality control, right? So then we say number of bases is the first quality control thing. We'll look at more quality control. Anyway, on concept, I'm just saying that you must have an SOP and you must record what the information is.
Ok, donc quand vous partez de ce cassage, vous devez avoir par exemple chaque étape, quelles sont les vraies choses qu'on veut avoir. Donc pour chaque étape, vous dites je veux avoir ceci, je veux avoir ceci, je veux avoir ceci. Et après, c'est cette SOP-là que vous allez utiliser pour vous assurer que ce que vous avez fait, ça respecte ces étapes-là.
Okay, just on English quickly. Illumina sequencing starts better at the one side, drops towards the end. This, as Naomi pointed out to me, this data is pre-cleaned data, so we don't see the dirt so much. But we know that in general, quality starts good on one side, drops at the end. Okay? So normally what you see is more like a drop like this into the bad section, and you can deal with that. Okay? And then the last picture that I want to show before I hand back to Stanislas, what did I just do?
Oh, you just clicked on the image, so just.
So how do I go back? Yeah, okay. And the last thing that I want to show, the average quality again, if your average quality is, the average quality is the high 30s. This is very good, okay? But that's Illumina. Illumina has good quality, right? Generally. Where'd my mouse go? No, I'm working on the wrong keyboard. And then here, it shows that so we often get this, that the very start of the read, the quality can be not so great, and then it moves on, okay? And then over to Stanislas, who's going to explain, I think, the very important question of GC content. Okay, most very important thing. How do you know that what you sequenced is what you thought you sequenced?
l'un des éléments qu'il faut que vous regardez quand vous allez se passer, chaque organisme a ce qu'on appelle son contenu GC. Donc pour le Mpox, quel est le contenu GC? Mpox GC content.
Well, must I look it up? Mpox virus genome. It's a low GC organ, right? Give me a second. Give me a second to just look it up.
Cherchez sur Internet Mpox, le contenu GC du Mpox.
GC content 33%. Look where it is.
Donc, ouais, on est pratiquement autour des 33. Ouais, donc, on est autour du nombre attendu. Donc, ça veut... Supposons par exemple qu'on sait qu'on doit être autour de 33. S'il vous plaît, on doit être autour de 33. Et on regarde ici, on est à 56. Qu'est-ce que ça veut dire?
Okay.
Ça veut dire quoi?
Yeah, is this good? Is this looking right?
Yeah.
I think we must pack up and continue tomorrow, but I'll just explain in English, right? So every organism, the genome has a characteristic GC content, okay? So Mycobacterium tuberculosis, who knows the GC content of the Mycobacterium tuberculosis genome? Mycobacterium tuberculosis GC content? Nobody knows the Mycobacterium tuberculosis genome GC content. Who are you? 65%, okay? These are important things to remember, okay? The GC content, most of Mpox virus genome is A and T, not G and C. GC content is here around 33%. So if you sequence something, okay, you think it's Mpox. This graph, GC content is showing 55. Can't be Mpox, you know? So it's the first thing I always look at. I had some cholera, Vibrio cholerae genomes. Vibrio cholerae genome GC content 49%. Okay, and I got these Vibrio cholerae genomes. It said GC content 58%. I was like, cholera, you know? It's not, because the GC content of cholera is 49%. Okay, and then turned out to be Morganella morgani and other things. Okay. So my point is always, this is when you keep, so we are discussed in another project with ASLM, we are discussing which figures should you keep for every sequencing run, and this is one of the ones that we say you should keep. For every sample, write down what was the GC content. So it goes into your logbook. Okay, and then we're done. Yeah.
Ce qu'il explique, c'est si tu as un contenu GC, tu attends par exemple 33, un exemple. Et puis tu finis, tu regardes le contenu GC, tu as 66. Qu'est-ce que ça veut dire? Ça veut dire que ce n'est pas l'organisme.
En fait, chaque
organisme.
il y a un CTG. Mais pour Canada, il y a son propre pourcentage qui est